Algebra 1, Lesson 2, and we're also going to look at Lesson 3 in this video. Lesson 2 is all about looking at different expressions and being able to identify the different parts, things like variables, expressions, constants, but also being able to look at the differences between the terms. Okay, and we will also look at the different factors of a specific term and how we can see that, especially with complicated ones like if we see fractions with a variable involved. So first, let's look at the different parts of an expression. First, a coefficient. If we look at the definition of a coefficient, we can see that this is the numeric factor of a product, including a variable. What this is saying is that if we have something like 5x, we are looking at the fact that this is a product, 5 times x. It includes a variable x, but it also includes the numeric part, the number 5. So we would say that 5 is a coefficient. A constant, on the other hand, is a quantity which value does not change. So when we look at 5x plus 2, since 2 doesn't have a variable on it, it's not going to change. Regardless if x is 1, -1, 100, a billion, it doesn't matter. That 2 is still going to be 2. That's a constant. Whereas a variable is a letter used to represent a number. You guys are very familiar with this, but that x, we can replace that with different numbers to see what changes the expression. So let's define some of these parts. So let's look at our one right here, 3 minus x. 3 minus x. So first off, I can see this 3 is alone, so we're going to call that a constant. We know x, since it's a letter, it's going to represent a number, so that's called a variable. Now the question is, do we have a coefficient in this case? And yes, we do. We're looking for something that is being multiplied by x. And since technically in front of this x we have a 1, we are going to have a coefficient, but it's not just going to be 1. Since it's a negative x, -1 is actually our coefficient. This is our coefficient. It is the numeric value that is being multiplied by our variable. Okay? Similarly, 71 is a coefficient, 32 is a coefficient, and then our variables in this one. A is its own variable, B is its own variable, and V is its own variable. Question is, do we have a constant? And in this case, no. We don't have something that is added on, subtracted on, that doesn't have a variable attached to it. So we would say we just have coefficients and variables here. All right, so we need to be able to label the different parts of an expression using things like coefficient, variable, and constant. Next, we need to be able to look at specific terms and say, what are the factors? Well, if you can remember back, factor is a part of a product. So factor times a factor gives us a product. So if we have a factor multiplied by a factor, we get a product. Sorry about the board, folks. Don't know why it's doing that. Let's see if I can erase it. All right, so if we look at 7VW, that has some very specific products. Okay, so if we look at that, we can say, all right, well, what are the things that are multiplied together? Well, we would say that 7, V, and W are all factors. Okay, -5 is a factor, R is a factor, and S and T are factors. The question comes when you come to something like 5x divided by 3. Now, a lot of people just want to say 5 and x are factors, which if we had an expression that was just 5x, I would say yes, those are factors. But unfortunately, we have that divided by 3. Well, I'm going to rewrite this to say I have 5 over 3 times x. Those are definitely the same thing. Those are equivalent. which means I have two things multiplied together here. I have 5 over 3 multiplied by x. So those are my factors, 5/3 and x. Just to give another example or two, let's say I have negative x over 2. Well, this means that I really just have negative 1/2 times x. So my factors are x and negative 1/2. When you see something like a fraction that you need to figure out what the factors are, I would highly encourage you to split it up into the fractional part times the variable. Then you can see clearly that this is a factor 1/2 and x is a factor. Those are the two things multiplied together to get your fraction. Okay. So far we've seen constants, we've seen variables, we have seen our coefficients, and we have been able to see our factors. The last part of this lesson is being able to see what are the terms. And like we talked about in class, a term is always separated from a different term by an addition or subtraction sign. So if we look at 5x plus 2, that plus sign in the middle there tells me that something is being split up. Two terms are being split up. 5x is a term and 2 is a term. So I always like to put little slashes in between so that I can say we have two different terms here. Similarly, 71ab plus 32v, we have two terms. 3 minus x, well, that subtraction sign separates them, so I have a term of 3 and I have a term of negative x. That subtraction sign goes along with that x. We can't forget about it. Very important. And lastly, this long one, we have 4 different terms. 3x is a term, positive 5m is a term, negative 8 is a term, and m over 2 is a term. 4 different terms in that big long one. So with expressions, we have lots of different things that we can look at. You need to be able to define the different parts of an expression so that you can then use that later on. Okay, so lesson 2, all about expressions. Lesson 3 is all about really exponents, taking expressions and simplifying them using the product property. As you will remember, the product property deals with our exponents. So we have different parts of our exponential problems. Our base, okay, which is a number used as a factor. Exponent shows how many times the base is multiplied. In the power, really we're just talking about the entire thing. So to give an example, 5 to the 3rd power, our base is 5, since 5 is the number that we are going to be multiplying together many times. 3 is our exponent. It tells us how many times we need to multiply 5. And the power is the entire problem, 5 to the 3rd. Okay, so base, exponent, and we have power. Power doesn't get used super often, but mostly you'll hear it when we say something like 5 to the power of 3. That's when it comes up the most often. Simplifying the expression, really, when you see this in a homework or a test, whatever it might be, it just means we need to multiply these things out. So in this case of 1/2 to the 5th power, I would just say we have 1/2 times 1/2. Sorry, let me erase that. We have 1/2. Let's try that again. Times 1/2 times 1/2. We're going to do this 5 times, times 1/2 times 1/2. All right. When we multiply all that up, we get 1 over 32. Okay. Our base is 1/2 since that's being multiplied. Our 5 is the exponent, and the whole thing, our power, is 1/2 to the 5th power. Okay. So let's just continue on by talking about our different product rules that we have. All right, let me just erase this really quick. We know that when we talk about different expressions that have variables especially, we need to be able to simplify. So if we are multiplying powers with the same base, we know that we need to add the exponents. We're saying that I have this many things multiplied together times this many things multiplied together, so I have a total by adding the exponents. Dividing, on the other hand, we need to be able to subtract the bottom exponent from the top exponent. Let's focus on the multiplying powers. So x to the 5th, x to the 7th, x squared. Those are all being multiplied together. They have the same base, which is great. We must have that. So we just add 5, we add 7, and we add 2. 5, 7, and 2. Which means that I have actually 14 x's being multiplied together in total. Let's look at the other ones. We have a to the 3rd, a squared, a to the 4th, n to the 6th, n to the 7th. A lot of times people will look at this and say, well, I need to add together 3, 2, 4, 6, and 7 and call it quits. But we can see that we have different bases. We have a bases and we have n bases. We need to deal with those separately. So we look at the a's and say, I'm going to multiply these together, so I add the exponents to say 3 plus 2 plus 4. That gives me a to the 9th. Then we have our n's. 6 plus 7, we get n to the 13th. Our final answer, we just say we have a to the 9th times n to the 13th. That's all we need to do. Okay, so when we are multiplying things with the same base, must be exactly the same base, not just close, needs to be the same, we can add the exponents. All right, next, when we divide things that have exponents, we need to subtract. So really quickly, let's look at that. Oop. All right. Oop. Good grief, what am I doing? All right, there we go. So we need to divide. So if we take a to the 3rd divided by a, that just means that we need to subtract. So we take a to the 3 minus 1. Since this a down here just has a 1 as an exponent, and we get a to the 2nd power as our answer. Similarly, over here we would say b to the 4 minus 13. Well, that gives us b to the negative 9th, and like we've talked about, we don't like to keep things with negative exponents, so we need to get rid of that by moving it to the denominator, moving it to the basement, and 1 is going to be our numerator. So we have 1 over b to the 9th. That would be a proper way to finish that problem. So when we are dividing things that have the same base, good thing we have a's and we have b's, we need to be able to subtract. All right, let's give just one example. We did the t-flops and p-flops in class, so let's look at a different one, okay? So you probably heard about gigabytes. We also have other types. We have exabytes and yottabytes. We are told that 10 to the 6th exabytes are in a yottabyte, and 10 to the 9th gigabytes are in an exabyte. How many gigabytes are in a yottabyte? Well, this is just a rate problem that we need to change 1 yottabyte, I'm going to represent that with a y, to our end should be gigabytes. All right, we need to see how many we have. Well, we are told that 1 yottabyte, I put that on the denominator so we can cancel it out, is the same as 10 to the 6th exabytes. Well, we're not quite there yet because now we're in exabytes. So we multiply by 1 exabyte, okay, we put it on the denominator again so we can get rid of it, is the same as 10 to the 9th gigabytes. We can cancel out our exabytes, and really we just need to multiply across the top. Well, just like we've seen, if we're multiplying things with the same base, and in this case we have a base of 10, we add the exponents. So we would say there are 10 to the 15th gigabytes in 1 yottabyte. Hopefully this was helpful. This is lesson 2 and 3 of Algebra 1. Hopefully it helps you in your homework or your studying.